All right, today we're going to take a look at the shell sort method challenge that was presented by Topcoder. Now, shell sort is just a little bit different than a couple of the other sorts that we looked at, although it is very, very similar to insertion sort. And we're actually going to use some of the insertion sort methods to make shell sort work out. Now, what this sort does is it compares values that are separated by a specific gap in the indices of each value. Um, and so what it does is it allows for the sort method to actually break the array into sub-arrays and compare up to a certain point in that main array. And when it does this, it reduces the total number of iterations that are going to occur for larger arrays. Now, with smaller arrays, the difference between shell sort and insertion sort really isn't that great. But as the arrays get larger and the gaps become more pronounced, then what we're going to see is an improvement overall in the time it takes to get these values sorted using shell sort. Now, we can go ahead and take a look at the method, but what I really want to do first is kind of show you what it does before we take a look at the method. So first, let's go ahead and run the tests for this. So clear the screen, and we're just going to do a simple bundle execute rspec command on this. And so we get 7 examples and 0 failures. Now there's a whole bunch of junk in here, so let me go ahead and comment out my print lines. I'm going to do this just to show you that the methods actually work and that we get a good, clean, clear test for all of these methods. So let's run that command one more time. Still getting a little bit of extra printing in here. So let me come out one more pass and then one more time. Oh my. Let's see. All right. So there were a few lines that I'm commenting out, and these are going to be my print lines that kind of show you what's going on with this this particular method. And it's really important that I have these in here during the demo because if you don't take a chance to actually see what's going on, it kind of just looks like an insertion sort. And so I have several different areas here where I'm actually printing to the console to show you what's happening with each pass on that shell sort. All right, so let's do this one more time. Okay, so we have 7 tests. Move the larger integers to the end of the array, smallest integer to the front, handles empty array, handles length of 1, sorts from least to greatest, handles 0 appropriately, and handles negative numbers appropriately. So again, we see 7 tests and 0 failures. We have the unsorted array that's being passed in and the sorted array. Okay, so now that we've seen the tests actually work with this, let's go back, clear our screen one more time, and we're going to go back and we're going to remove the comment marks from these print lines. And again, the whole reason for this is that I want to show you what's happening with every single pass of this shell sort. Okay, so save my work, and then we'll open this up all the way just so we can see everything that's going on here. All right, so let's go ahead and run the file. Here we go. Okay, so again, what I'm doing is I'm creating an array of random numbers between -100 and +100. And I'm creating that array that is 10 integers or 10 values long. So what we're going to see here is a huge display, a wall of arrays. But if we take a close look, and we are going to take a close look at each of these values where it prints and see what's happening here. So let's go ahead and run the file. All right, so let's scroll all the way up to the top. Okay, Now, what we're doing, and notice I've labeled each of these prints with pass numbers, and this is the pass 0, pass 1, pass 2, etc., all the way to the end. Now, take a look at this first pass. It seems like a really, really small pass. And so my random array is 26, negative 50, 20, negative 1, 98, 83, 11, 35, 75, and 40. Now, the reason I'm using 10 values here is because we really want to see what's going on with this sort method. Okay, so take a look at pass 0. Now, the top pass 0 is that unsorted array that we passed in first, the random array here. And now what we're doing is we're checking the values at that gap that's presented, which we'll talk about in a minute. So we're checking the values at array 0 and array 4. And the value at array 0 is 26, and array 4 is 98. Now, remember, the smaller values are going to be pushed to the left of the array. The larger values are going to be pushed to the right. So 26 is smaller than 98, so nothing's going to happen in this particular pass. So it goes on to the next pass, and it checks the next number. So checking array at position 1 versus array at position 5. And notice it's holding that gap. Now, array at position 1 is negative 50. Array at position 5 is negative 83. Now, negative 83 is less than negative 50, so it's going to swap those two. And yes, swap, I said. Now, this is an in-place sorting method, so those two values are going to switch places. No extra memory is being allocated to this. Now, what's happening here with this gap? It is testing this value here at 0 and at 4. So that's 0, 1, 2, 3, 4. And it's testing that value, and then it's moving up and testing 4 again. Now, we'll see what happens as we get further down. We do have this extra 1, 2, 3, 4, so it could test negative 75 in this whole bit too. But we'll get to that, and we're actually, as we scroll through this, we actually see what's happening here and why it's only checking one item or one pair here in these first few passes. Okay, so the next pass, it's checking array 2. So array 2 is 20, array 6 is 11. 11 is less than 20, so swapping places. Pass 3. Checking array position 3, negative 1 and 35. Negative 1 is less than 35, so nothing swaps. Then notice that pass 4, we're actually checking two values here. Now, the reason for this is because it checks the value at the furthest side first. So it's actually checking array position 4 and position 8. So 0, 1, 2, 3, 4, and 8, which is negative 75. So 98 and negative 75, and it swaps those two values, okay? Now, it then checks that new position, which is negative 75 here, where the 98 is, and the 26, which is the first position in this array. And so it's going to say, okay, now, negative 75 is less than 98, so we'll swap. And then it's testing 26 and negative 75 and saying negative 75 is less than 26, so we're going to swap again. So we've had two swaps in this pass in which 98 moved to where 75 was, 26 moved to where 98 was, and negative 75 moved to where 26 was. So again, we checked these two values. Negative 75 was less. Then we checked negative 75 against 26, and negative 75 was less. So again, two swaps in that pass. Now the same thing happens in pass 5. It checks array position 5, so 0, 1, 2, 3, 4, 5, so that's negative 50 and 40. So that's these two here. Now 40 is greater than negative 50, so no swap there. So now it checks 1, 2, 3, 4 and says, okay, is negative 83 less than negative 50. Now you can see here, this is sorting each of those values along that gap. So eventually when we get further and further down, we are doing essentially fewer and fewer swaps with each of these positions, because those positions are swapping through each pass. Now we come back to position 6, and we're checking 0 and 1. Now you say, well, whoa, what's going on here? This is a really, really close check. Well, that's right, because every time that we've moved down through this, our gap has actually reduced in size. Um, so the gap between the two are going to be divided by, well, we'll see in a minute. So now we're testing 0 and 1, and 0 and 1, we do have a swap, and so we get that swap. Then the next one, we test 2 and 1, so 2 and 1, no swap, and 0 and 1, again, no swap. So again, no swap, but we're testing each of those values just to make sure. And then we're going to test 3 against 2, so 3, position 3 is -1, position 2 is 11, so those will actually swap. Then it's going to test 2 and 1. -1 is greater than -75, so no swap, and again, no swap. So as we're moving further and further along, we're only having to swap the values that are closer to the right-hand side of this major array. Now the next one tests 11 and 26, and these are in order, so there will be no swaps all the way down. But again, it has to check. It's a really dumb sorting method, as most computers are. It has to check all the values just to make sure that they're sorted in every single pass. Then it tests 4 and 5. Now 5 is less than position 4, so it will swap, and then it will test 4 against 3, and -50 is less than 11, so it'll swap. Then it tests -1 versus -50, swap again, and -75 against -50, no more swaps. Okay, so now everything from position 0 to position 5 is currently in sorted order. So -83, -75, -50, -1, 11, and 26. All of those are in sorted order, which is a great, great thing, because that means the only thing that's not sorted is what's at the right-hand side of that. So as you can see, just like insertion sort, once it starts sorting, everything to the left of that checkpoint is sorted. Everything to the right is in that unsorted subarray. Okay, and so at this point, we're basically doing an insertion sort. We're just checking those last two values in that sorted array versus the unsorted array, and then swapping them as we go through. Pass 11, again, test 26 versus 20. 20 is less than 26, so it swaps. 20 is greater than 11, so at this point we know, as humans know, that everything below that is in sorted order. So again, we just keep going. Next check is position 6 and 7. 7 is greater than 6, so no swap. And again, all of these are already sorted, so no swap, but again, it has to check. Then position 7 and 8. 98 is greater than 35. Again, no swap. All of those are in order. Then pass 14, we're checking position 9 and position 8. Now 40 is less than 98, so you'll get a swap there, but 40 is greater than 35, so no swap. Okay, and now we have everything in sorted order at the bottom. It only took 14 passes. Yeah, 14 passes is quite a few, and should our array be tons bigger, we're going to get tons more passes. But as you can see, it moves everything to where it should in order to sort this array. Then finally, the sorted array is returned, and we are finished. So let's go ahead and take a look at the method now, so that now that we finally understand or have a good view of what's going on here, using those prints to console. All right, so the method itself. Now, what I've done is I've set a couple of values, and now that I don't need the visual display anymore, I'm going to go ahead and get rid of the extraneous values before we actually talk about this. So we don't actually have to talk about the extraneous code that I have in here, just to show that stuff at the bottom. It was really good about putting in a delete queue for each of those methods. And so that's really it. Okay, so we're just going ahead and running the shell sort right now. And the first value that I set up is just a value, it's a test value, and I'm basically just saying, hey look, I'm setting a really short variable name to test or to set this at the array.length. I could just pass in array.length for this, but that gets really, really long after a while, and I'm actually passing it in a couple of places, so I just gave it a variable name, len. It's a short, sweet, easy name to type in, and it doesn't kill our line length at all. Okay, now the next value I'm setting is called gap. Now, we talked about gap before, and the gap is the space from one index point to the next. And I'm setting this at index point 1 because I'm going to run a method that will actually figure out a good distance between each of these passes at that first pass originally, so that it can go back and say, hey, look, I've run this gap, and now I have something to test against and to actually swap values at that gap point. And then as we go through, as we roll through this method, that gap is going to get smaller and smaller and smaller until it eventually is 0. And when the gap is 0, the loop will stop. Okay, so the method that I use is I'm just setting the gap to 3 times the gap plus 1, while the gap is less than length divided by 3. So I'm basically just setting that gap as just over a third of the length of the array, so that when it rolls through, it's testing those links, and it gives the gap a good place to say, hey, now we can cut this in half, and that will be on our new gap. Okay, so while the gap is greater than 0, so while there are still potential swaps in this array, from the point of gap all the way to the end of the array, I'm going to iterate over the values. Then what I'm doing is I'm setting a temporary value j to that first value I. So j is going to equal gap here, as well as I. Now, while j is greater than or equal to gap, now this is very important because this tells us when we need to check multiple times through each iteration in order for the values to swap several times depending on where they fit in that subarray built by the gap. So I'm testing j minus gap. So the first pass, this j minus gap will be 0. So I'm testing array 0, whether or not that is greater than the point at, or the value at index j. If it is greater, then we swap. If not, then I subtract j, or the gap from j, and we continue on from there. Now these first couple, as we saw here when we printed it out, that immediately moved us on to the next pass, because when we subtract j from, or a gap from j, j is then less than the gap, and so it moves on to the next pass. And that was the value that I had set up here, the pass value, so that we could see which pass we were in. So another value I need to get rid of. Now, once it breaks that, then it moves on to the next iteration for the loop up here, resets j to that new I value, and then it runs through that iteration again. Now, it will keep doing this, and as it runs through each iteration, before it starts the next iteration, it divides the gap by 3. Now all that does is it shrinks the size of the gap between those rotations, and this could actually be divided by anything. And if I divided it by 2, then the gap between the two would just get smaller, but it would still work in pretty much the exact same way. And depending on the size of the overall initial array, then we don't want to make this gap reduction too small, because then it's just taking a ton of swaps, and it may as well just be insertion sort at that point. And we don't want to make it too large, because if we make it too large, then we'll get through several more iterations of the outer iteration before we actually get to the smaller swaps, which would then potentially give us a ton of swaps. Remember, at the end of our iteration, we had to go through every single position. So I mean, that could just get a little bit tedious. So 3 is a pretty good number. Again, it doesn't have to be 3. It all just depends on the size of the arrays that we're checking. Once it's made it all the way through and the gap is then 0 at the end, then we return our array, and when we return that array, it should at that point be sorted. Okay, so again, that's my shell sort method. If there are any questions or comments, please leave them in the forum on the Topcoder Veterans Board, and I will take a look and respond to them as soon as I possibly can. All right, thank you guys. Have a good day.